Namaskar. So we have already seen PIC16F877 features and its detail. What is the overview of this particular device and how it is very useful to our automotive, industrial, appliances and consumer applications. So let's quickly go through the features where like it has two PWM 10 bits, it has 256 bytes of EEPROM data memory, it has ICD functions of for programmings, it has 25 milliampere capability of syncing and sourcing the current in its IOs. It has self-programming capabilities. Our main focus is working on 40-pin PDIP package. It will look like this, okay? And the development softwares are for this is MPLAB X IDE and MPLAB X8 compilers, okay? So X is for 32-bit or 16-bit compilers, X8 will be for 8-bit compiler. And PIC-Kit 5 and ICD5 are the debuggers for programming this particular microcontroller. And in short, I had shown you in last video like what were the like features for PIC16F. So it has a program memory size of around 14 KB. It has a RAM size of 368 bytes. It has data EEPROM of 256 bytes. It has pin count of 40. It has a operating voltage of like maximum 5.5 volt and minimum 2 volt. So it is very suitable for working with like 3.3 volt and 5 volt. Okay. Now it has 8 ADC channels and it has number of comparators too. It has SPI, I2C, and it has like very all other things are fine, right? So this is the way we have understood what are the features and what are the parameters. In this video, what we will see is we will see the pin descriptions, like what are the pins and what is their functionalities one by one, and that is very useful for your understanding. Once you go through each pins, you will be able to like find out while writing a program that what are the functionalities of each pin. Okay, I don't want you to just learn this microcontroller. I want you to be in a position after like completing this particular tutorial, you should be in a position to design and develop this circuit by yourself. Okay, so let us see. This is actually 28 pins. I will be taking 40 pin only, so let's go with 40 pin. So our prime focus is to work on 40 pin device. Okay, so this is our 40 pin device. Now coming to the fact that it has like all the pins organized something in this manner, 1 to 20 pin in other side and 21 to 40 pin in other side. So 20 pin left side, 20 pin right side, and you can see it has two versions, PIC16F874A and PIC16F877A. Okay, so 874A and 877A both are pin to pin compatible and they are 40 pin device. Okay, I'm not going to tell you directly what are these pins because you will be able to understand much better in the pin description like page. So you can see MCLR bar. So this is actually master clear like pin, or AN0 is analog device analog pin or basically ADC pin, and RA means port pin. This is A0 A1 like that. So all these things will be like seen in the pin description lines. In short, if I tell you, you can see, you can find out by your like pin name itself. So this is your like reset pins, this is your port pins as well as analog devices pin. I mean analog input pins, basically it is ADC pin. Same way this is also port pin and ADC pin. It has like V reference pin. Okay, this is negative, and V reference is pin positive. This is used for, V reference is used for like ADC. So negative will be grounded and positive will be like sorted with some capacitor, or you can put external like voltage supply to this. So I'll teach you while designing the circuit. Okay, similar to this other things are there. This is my VDD power supply. So pin number 11 is power supply pin. Okay, here only you will be giving the power to this, either 5 volt or 3.3 volt. And this is your ground pin VSS. This is your oscillator input and this is your oscillator output. So you will be connecting one oscillator. So one pin will be connected to oscillator 1, another pin will be connected to oscillator 2 pin. Okay, so this is how it works, and it has like different ports. RA means port A and RB means port B, RE means port E, RC means port C, RD means port D and RB means port B, right? So it has, like port A, B, C, D, E. So this is how port pins are identified, okay? And in each port, there will be some 5, 6 pins will be there, okay? So you can see port B is 0, 1, 2, 3, 4, 5, 6, 7. So this is how in port B, it has total 8 pins, okay? Whereas in port D, what will you see? D4, D5, D6, D7, and D2, D3 is also there, and D0, D1 is also there. So D0, D1 to D7. So this D has also 8 pins total. Similarly, C will be there and A will be there. Okay. So I hope you have a rough idea about the pins and like how they are organized. You can see you have two supply pins. One VDD is here and this is your ground. So pin number 11 and pin number 32 both are supply pins. So both will be giving like getting the same voltage supply. And pin number 12 and pin number 13 are ground pins. All right. Good. So shall we directly proceed into the pin descriptions? One more before proceeding to pin description, we'll go ahead with like this device features. So you can see pin 16 PIC16F877X is having like different like device categories. So it has 73 series, 74 series, 76 series, and 77 series. Okay. So our aim would be to work on 77 series only. It is pin to pin compatible to 74 also for particular pin configuration. Let's say 40 pin and this 40 pin both are pin to pin compatible. Okay, this 40 pin and this 40 pin both are pin to pin compatible. All right. Now in short, if you see the operating frequency is DC to 20 megahertz, that is like you don't have to apply any frequency also. Without frequency it will work. Then it has a reset pin like power on reset, brown on reset. Okay, and it has a flash program memory of 8 kilobytes. Okay, or it is in bit words, so it is 8 kilowords. And then data memory is 368 bytes, EEPROM is 256 bytes, interrupts are 15 interrupts are there. Okay, it has IO ports as I mentioned just now, port A, B, C, D, E, and then it has timer, three timers are there, timer 0, 1 and 2. And then capture, compare or PWM modules are there, two modules are there in this. It has serial communications, that is MSSP, and it has UART as well. Okay, then it has like parallel slave ports. Okay, so parallel communication, it has parallel slave ports. Then it has 10-bit analog to digital module, so it has total 8 channels, so 8 ADCs you can connect. It has two comparators as well, and you can see it has instruction sets 35. And our aim is to work with 40 pin PDIP package, and next tutorials we will see 44 pin TQFP also. Okay, but this is most versatile used 40 pin PDIP. It is because it is very sturdy, as you can see. It is very sturdy and easy to handle, and it is like uh, I mean well accepted by many universities as well as like automotive applications and appliances. All right, so let's directly jump into the pin description. Okay, good. So what I have done is I have taken this pin description from the data sheet of this particular device. So I'll directly tell you the data sheet is organized in, like in this pin description, this is organized in this fashion. This is pin names. Okay, just now I was telling you. Okay, let me take this here so it will be easy for you to make out. Okay, so what I have done is this is my 40 pin package. So 40 pin, this one and PD. Okay, so first like a column we will see. So first pin is oscillator 1 or CLKI or oscillator 1. So this is pin number 13. So if you see pin number 13, it is oscillator 1 CLKI. And this you can see it is oscillator crystal or external clock input. Okay, so oscillator crystal input or external clock source input. So you have to basically connect the oscillator pin into this. Okay, and in pin 14 it is oscillator output, so oscillator or clock output, so you will be taking clock output. So basically these two pin will be connected to oscillator crystals. Okay, and one will be input clock, another will be output clock. So if you want to measure your like connected oscillator frequency, how much it is giving, you will be able to find it out very easily. Okay, So what I'll do is I'll open the data sheet, and it will be easier for me to show you the pin descriptions. Hope you have understood the pin organization. Now directly I have to just show it to you what is the pin name and what is their functionalities. Okay. So let's open data sheet. Once we go to the data sheet, you'll have to go to pin descriptions. Okay. Good. So we have reached to pin description here. As you can see, this is PIC16F873 and 876. So this is not our interest. Our interest is to go ahead with PIC 77A. Okay. So PIC16F877A, and this is our interest, which was PDIP package. So we have understood about pin number 13, it was oscillator input. Pin number 14, it was oscillator output. This is MCLR, that is master clear input or programming voltage output. Okay. So whenever you want to reset your microcontroller, you can connect one switch to this particular pin, and it will you know like uh, uh, reset the microcontroller. So this is pin number 1. Okay. Similar to that, RA0, AN0. So these are digital IO, that is RA0, and analog input 0. Okay. So 0 means ADC 0, and RA0 means digital input and output both. So it can be programmed as input pin as well as output pin. Like you can drive some LED, or you can drive the same LED acting as a sink. Okay. So an LED can be connected as a sink to the microcontroller as well as sourcing from the microcontroller. Okay. So both I have already taught you while connecting an LED through a microcontroller how to connect it. Similar to this, I'm not going to very deeper. RA1, AN1 both are same. Then RA2, AN2. It has another functionality of VREF minus. So VREF minus is analog to digital reference voltage input, low input. So it will be negative. Okay. I mean zero input. Then C Vref is comparator V reference output. Okay, so if you are using comparator, then you can utilize this as a comparator reference output. So how it works? Similar, simply for analog to digital, you can just simply ground this pin. That's all. You don't have to do anything. Okay, and V reference plus, what you can do is it has digital IO, it has analog to digital converter 3, and it has analog to digital reference voltage input also. So if you want to use it as a reference pin, then you can connect through a capacitor. Okay, that's it. Coming to the fact that RF4 TOCKI and C1 out. Okay, so you can see pin number 6 is this one. So it has digital IO. Wherever RAX is coming, like 0, 1, 2, 3, 4, that are all digital IO, like input output pins. Okay. Then TOCKI is timer 0 external clock input. Okay. CK means clock. So you can identify by the name itself. T0 means timer 0. CKI means clock input. Okay. So timer 0, external clock input. C1 out means comparator 1 output. Okay, so comparator 1, if you are trying to use as a functionality, then you will be using at output. Okay. Similar to this, RA5, AN5 is well understood. Coming to the fact that SS bar is slave select. Okay, so SPI slave select input. So if you want to select one, like a EEPROM or maybe another connected IO expander or any other device that is connected through SPI communication. So this SS pin will be used as a select input. Understood? And C2 out is comparator to output. Okay. So I hope you have a good understanding of this pin configurations, how it was connected. You can see how it is organized also. This is IOP. Okay, and this is buffer type. So you can see here legends. I means input, O means output, IO means input output both. Okay, so you can see AN4 is acting as I, means only input you can give when you want it to be analog input kind of thing. But if you want it to be IO pin, then it can be input as well as output both. Okay. If it is P, then it will be acting as a power. So I'll show you VSS and VDD, that will be shown as power. Okay. If it is blank, then it will be not used. If it is TTL means transistor logic. Okay, and ST means schematic trigger inputs. Okay. Good. So you can see ST means schematic trigger input, TTL means TTL logics. Okay. Now coming to the next pins, pin number 33. So pin number 33 is again, like digital IO, then interrupt pin. So see, this is complete pin name. This is complete pin name, and this is separated. RB0 is what functionality, interrupt is what functionality, like that. Okay. RB1, RB2 are just the, like digital IOs. Then RB3 is digital IO, and PGM. PGM is what? So PGM is basically low voltage ICSP programming enable pin. So PGM will be used for programming. So you have to make a note of this PGM pin. Okay. PGM one pin is there, which is pin number 36. Okay. So this you have to keep in mind. This will be used as a programming pin. Similar to that, RB4, RB5 are digital IOs, and PB6 is digital IO, but PGC is again programming pin. So it is in-circuit in-circuit debugger, and ICSP programming clock. So my PGC will be used as programming clock. So PGM is enable pin and PGC is programming clock. Okay. Then PGD is again going to be used as, this is PBC. PB7 is used as digital IO, but PGD functionality will be used as again debugger programming data. Okay. So PGD is programming data. Understood? So PGM is programming enable pin, PGC is programming clock pin, and PGD is programming data pin. Okay. Got it? Next, coming to the fact that RC0, T1 OSO, T1 CKI. So T1 means timer 1 clock input. Okay. RC0 you know already. This is digital IO. T1 OSO is timer 1 oscillator output or timer 1 oscillator clock input for TCKI. I mean T1 KI, T1 CKI. Okay. Similar to that, RC1, T1 OSI and CCP2. So T1 OSI is what? Timer 1 oscillator input. So T1 OSO is timer 1 oscillator output, and T1 OSI is timer 1 oscillator input. Understood? Now CCP2 is capture 2 input. Okay. And same way RC2 is, this is port C digital IO, and CCP1. So see, CCP2 is capture 2 input, CCP1 is capture 1 input. Okay. So this is how you can find out. Okay. Next, RC3 is digital IO, then SCK and SCL. So SCK and SCL, I can directly tell you that this is SPI clock and this is I2C clock. Okay. So if you are using SPI, like communication mode, then this will be used as clock input output. Okay. And if you are using it as I2C communication mode, then this will be used as I2C serial clock input output. Okay. Next, RC4 is digital IO, which is pin number 23, and SDI is SPI data input. Okay, and SDI is I2C data output. Okay, so in I2C, basically two signals are used. One is SCL, that is clock line, and one is SDA. So SCL will be this one, and SDA will be this one. So pin number 18 and pin number 23 will be used for your I2C communication. If you want to use it as SPI communication, then it will be used as SCK and SDIP. Okay. Next, SDO is again a part of SPI data line. So it will be SPI data output, and then TX and CX. So CK. So TX is actually UART pin. Okay. So if you go, it will be UART transmit. Okay. And then CK is UART1 synchronous clock. Okay. So if you want to use it as UART functionality, then it will be used as TX, UART TX. And similar to that, UART will also be there. So next pin is 26 pin, which is UART RX. So UART receive. Okay. And UART synchronous data is also functionality is there. So if you want to use it as clock line, I mean synchronous clock and data line, then it is fine. Otherwise, UART transmit and UART receive is also fine. And if you do not want to use it as a communication interface, then they can both be used for digital IOs, like digital input output pins RC6 and RC7. So hope you have a good understanding about all the pin functionalities and pin namings. Two more are there, which are pin number 19. So Pin number 19 is what? You can see PD0, so port D, 0 pin. This is digital input output pin, and PSP0 is parallel slave port data, okay? And parallel slave port data 1, okay? And parallel slave port data 2. So you can see, if you want to, like go ahead with parallel slave ports, then in that case, parallel slave ports 0, 1, 2, 3, 4, 5, 6, 7. So total 8-bit parallel slave port data it can be used, okay? So port D from 0 to PD7, these are all have functionality of parallel slave port 1 to parallel slave port 8, okay? Understood? So they can be utilized for 8-bit data communication together. Understood? Next, coming to the another part, it is RE0. So this is like port E, 0th pin, which is digital input output pin, and RD bar. RD bar is read control for parallel slave port. So suppose you are working with parallel, like a slave port communication method, then if you want to read the data, RD pin has to go low, right? RD bar means it has to go low, then only it will start acting. RD bar will be made high to like disable this read control pin, okay? So we'll see those things how to control them, but this is read control pin, and this is write control pin, and this is chip select pin for parallel slave port. So you saw for parallel slave ports you had the data lines, and then you have RD control, read control, write control, and chip select control. So this total put together is going to like make you possible for parallel port communication, okay? Next, coming to the another part, which is VSS pin, that is ground pin, ground reference for logic and IO pins, right? So you have to ground it, and these are pin number 12 and 31. And this is VDD pin. VDD pin is pin number 11 and 32. So you have to like positive supply for logic. So you have to supply, let's say 3.3 volt or 5 volt, whichever voltage level you are working on this. So this is how the complete like port pin description and their functionalities were there. So now we guys are familiar about the like complete port pin functionalities, and we have understood what are the different functions of each pins of 40 pin PD package of PIC16F877A microcontroller. So in in PIC16F877A microcontroller tutorial, what we will be seeing next is we will be seeing schematic design, okay? So in schematic design, since we have the understanding of each pin functionalities, now we will be creating a symbol and directly connecting the pins for different functionalities of, let's say, uh, push buttons or LEDs or dip switches, okay, or like UART functionalities or I2C or SPI, our programming functions, okay, like how to program this particular device, okay, and then parallel slave port, like communication, even timers, and then PWMs, okay, how you can get PWM outputs, understood, how to reset the device. So all these, like we will see one by one in the upcoming tutorials as soon as possible. So hope you have understanding of this particular device overview, and now we are ready to plug into the schematic design. So if you do have any questions or any queries, and if you do find this particular tutorial useful, like and subscribe my channels. Thank you so much.